Well, hello all, and welcome to another Gates Automotive webinar in our series that we've been running now for a couple of months. Today, I would like to introduce Frank Woodson, who's going to be presenting today's topic on the changing world of automotive coolant hoses. Frank is the training manager for Gates North America and has joined us previously, but is again available to present today's topic. So over to you, Frank.
Well, Priscilla, I certainly appreciate it, and thank you very much. And I want to thank everybody that's online with us today for being here. We've got a lot of great information for you today, and really, quite honestly, it's an important message for a number of different reasons. Excuse me as I get my. There we go. It's an important message, like I said, for a lot of different reasons. And it's not because coolant hoses are that sophisticated or that challenging or that complex. You know, they're a pretty easy piece of equipment to understand. They're not like a lot of other things within an automotive system that, really deal with your electrical systems or something within the AC system, AC compressor, something like that. But still, even though it's a relatively simple part, it plays a very important role in the overall strategy of cooling systems. And so that's what we're going to be talking about today. There are a lot of things about coolant hoses that haven't changed. Their role in the cooling system. They're flexible connections. They're moving coolant, throughout the system. But the other thing that hasn't changed is if that part fails, if that hose fails for any reason, chances are that vehicle is going to be in a stop mode. It's not going to go anywhere. It's going to have lost coolant and possibly enough coolant that it can't go anywhere. So it's in what we call a Nike mode. Some people will call it a Reebok mode. Some people will call it an Adidas mode. But chances are that if the hose breaks and the break is severe enough, that person is walking, to their destination or calling a service to get them towed in. So once again, it's very important that we begin to understand what's going on with these hoses. So what has changed with these hoses is critical. These hoses are constructed out of different materials. They still are flexible connections, but they may be connections that also have a purpose. And in the past, like I said, a molded hose was simply a flexible connection that, went from port to port and transferred coolant. Now these cooling systems may have a direct purpose within the cooling system. What we need to understand too is what are the new failure modes for these hoses? What has changed with these? So that's going to be important to know. And then it's also how do we recognize how the environment that's under the hood of the vehicle affects the components. So what we're doing is we're looking at an entire system situation. And you'll see it on the screen there. It's called the Gates System Smart Initiative, and this is critical. So it doesn't matter whether we're talking about the accessory belt drive system, whether we're talking about the timing belt system, whether we're talking about cooling systems, air conditioning systems, brake systems, it doesn't really matter. Everything out there now in the automotive world with today's vehicles is a system. And even though we may be making a repair to a particular part in that system, we still have to recognize what the causes and effects are in play with that system. So once again, with this particular presentation that we're doing today, we're going to be looking at how the hoses have changed and how it's important to understand the changes and how it affects everything. But we're also going to look at the cooling system and the overall strategies that are being encompassed in those cooling systems and what's going on. Because it's very important that we educate ourselves on the environment under the hood and how it affects the cooling system. But also we need to learn and we need to continually educate ourselves on what happens when the condition of the coolant begins to change. We've got a lot of good coolants out there that are perfect when they're brand new. We've got a lot of good manufacturers out there that are creating a lot of good coolant out there, whether it's inorganic acid technology, organic acid technology, doesn't really matter. Whether it's a hybrid, type technology. But what happens to that coolant if it's neglected or if that system isn't taken care of? We're going to talk a little bit about that as we go through today. But the bullet points you see on your screen right now are really the points that we're going to be hitting on, and really talking about the modular hose systems. let's talk a little bit about cooling systems. And we're going to use the Ford EcoBoost engine as an example as we go along here. But cooling systems serve two purposes, right? They're designed, number one, to cool the engine. And number two, they're designed to provide heat to the passenger compartment. But in all actuality, there is a third reason that we have the cooling systems. And this one's been around for a while. I don't think this is really anything new, but a larger, more important role has really emerged for the cooling system, and that's engine management. You know, it's the ability to precisely and to predictably manipulate the cooling system in order to get the engine to run better, to have it perform better, and also to make it more fuel efficient. So, like I said, as an example is the Ford EcoBoost engine. This is a tremendous engine. This is really cool technology. It incorporates a lot of different things, but basically, as you all know, it's driving the horsepower and the torque, the V8, into a V6 engine or smaller. You know, I mean, basically, it kind of works itself down the line. But like I said, it's an incredible engine technology. I actually had a person, I was talking to, they described it as race car technology. I mean, what was race car technology a few short years ago is now, engines like the EcoBoost engines. But what's really critical with these engines is that preventative maintenance is key. There have been a lot of issues out there, perceived issues with these engines, but a lot of those issues really derive from not taking care of the engine, not doing the proper oil changes at the proper time, not doing coolant changes at the proper time. So it's very important as the technology and the sophistication of these engines grow, it's very important that the preventative maintenance schedules that go along with these engines, correspond equally, that we're doing the work to the engine, and that reduces the problems. Because once again, this is high-tech stuff. These engines are using turbocharger technology, they're using high-pressure direct fuel injection, they're using variable cam timing, all to eke the most power and the most fuel efficiency out of these systems they can. So once again, it's pretty neat stuff. So let's talk about hoses just a little bit, kind of the evolution of hoses. 30 years ago, and I mentioned this before, but hoses were really simple. They were rubber. Back then they were made of what we called a chloroprene rubber, and we'll talk about that here in just a little bit. But they were just simple port-to-port connections. That's all they did. They transferred coolant, and they were connected to the radiator. They were connected to the various stems within the system with either a worm drive type constant diameter clamp or a constant tension clamp. So, clamping it was manual. It was very simple. The chloroprene rubber that we, just mentioned, or that I just mentioned a few minutes ago, really these hoses 30 years ago, Gates was suggesting that we should be replacing hoses every 3 to 4 years. The replacement cycle was relatively quick. Even though chloroprene rubber was a good, fairly stable rubber, it did have its issues underneath the hood, with the hood environment, with the heat, the vibration, everything that was going on. So it was a hose that you needed to change every 3 or 4 years. Then at about 1990, hose technology evolved. And even though the strategy of the hose didn't really change, what changed was the material that we built these hoses out of. So around 1990, we introduced a material called EPDM, which is short for the scientific name for it, which is ethylene propylene dimonomer. That's a product that we use in a lot of rubber materials that we use today because it is so good at not being compromised by heat and not being compromised by ozone and all these different things that are taking place under the hood. So this was a really good hose. But what it also did is it kind of took the attention away from hoses, because what was a 3 to 4 year replacement cycle on hoses, now with EPDM became a 7 to 10 year replacement cycle. EPDM was that good. Not to say that you couldn't have problems with the hose. It's very important that we're inspecting hoses every time we're under the hood doing service. But once again, we began to get a little lackadaisical with hoses because once again, we began to recognize that they literally were lasting twice as long as the hoses that we had before. Now, we're still using constant diameter clamps or constant tension clamps with these hoses, connecting them. We didn't get into quick disconnects until a little bit later. But one of the big things that the industry began to recognize about EPDM rubber was its ability to bond to the stem that it was connected to. So that would really lessen the opportunities for leaking. And, I mean, it didn't always do it. Anybody who's ever had a cold water leak on a vehicle during the cold months understands that. But EPDM was very good about sealing to the stem. So that was one of the pluses to it. Then about 20 years ago, the car manufacturers began to develop what we called at that point in time branched hoses. Branched hoses were simply just that. There was still no purpose to some of the branches, but what it did is it helped the OEMs conserve space, and it lessened the number of connections they had to make within the system. So once again, there was a purpose. We were directing coolant to certain areas, but it wasn't like today's modular hoses. So it wasn't long after the branch hose was developed that the OEMs really began to dive into what we truly call the modular hose. And modular hoses are unique in a number of different ways. Number one, modular hoses do have a purpose or can have a purpose within the system. They may not. They may still be straight connections, but those connections are made usually with quick disconnects and other things like that. But these modular hoses, they allow the hoses to be easily installed. And then once again, they allow the manufacturer to begin to develop these different strategies. Because once again, within these vehicles, we have turbochargers to cool. We have battery packs possibly to cool. We have all these different things that need to happen underneath the hood, and the modular hose makes that possible. So let's talk about the cooling system just a little bit. Like I mentioned before, the cooling system is absolutely critical from a number of different reasons. Number one, taking heat away from the engine. Number two, providing heat to the passenger compartment. Number three, being an engine management strategy. So there are a lot of different things going on here. When you really take a look at an engine and you begin to think of the temperatures that are developed as that engine fires, it's incredible. Peak engine heat can reach temperatures as high as, 4,500 degrees Fahrenheit. That would be, about 2,500 degrees Celsius. You've got average combustion temperatures between, 1,200 and 2,000 degrees Fahrenheit, or about 650 to 1,100 degrees centigrade. And when you realize that aluminum can melt at about 1,200 degrees Fahrenheit or 660 degrees Celsius, then you got to remember, hey, this heat has got to be removed very, very quickly. So we've got to think of the cooling system as a system and not a bunch of single components. These things are all tied together, and if one is not working, we're going to have issues. As a general rule in today's world, most cooling systems are not properly maintained. They are on vehicles, and vehicles today are running anywhere from 12 to 16 years old and can have as many as 250,000 miles, by the time, they retire themselves. So once again, the mileage and the time that these vehicles are on the road are, it's a really, really long time. And just from personal experience and from having been in the industry for a long time, it is one of those things that does have a tendency to be neglected. The Gates Corporation twice a year does what we call a warranty sort on water pumps that we manufacture. And it is amazing. Throughout the course of the week, we'll go through 1,000 to 1,500 water pumps, inspecting them for the various failure modes that occur. And more times than not, that water pump did not fail because of a manufacturing defect. It failed because typically, a lot of times, because of the condition of coolant or something that was causing that water pump seal to fail. So once again, it's very important that we take a look at the cooling system as a system. So what I want to do is just very quickly, and I realize that you all are very versed in this, but it's interesting to look at how tied in everything is in the cooling system. So starting at the very front of the vehicle, starting at the radiator, obviously we are introducing really hot, high temperature coolant, leaving the engine, entering into the radiator where it has to be cooled. This coolant is going to be cooled by the ambient, what we call RAM air, that is running through the radiator and condenser combination that's at the front of the vehicle. We don't show the condenser in this particular illustration, It's more in tune with an AC type presentation. But once again, that air is going through there, and that's what's drying the heat out of the coolant. Now, obviously, coolant has specific purposes. Coolant is a three-part mixture. Coolant is about 50% water, about 50% ethylene or propylene glycol, and then about 3 to 5% of what we call the inhibitor package, which has the inhibitor package that stops rust and corrosion within the system, has the color involved in it, whatever. But the water in the coolant package is the heat transfer medium. It is the AC refrigerant, so to speak, of that combination. It's picking up the heat out of the engine, it's traveling it around, it's introducing it to the radiator, and then the ram air is passing through and it's pushing the heat out of the water. It's actually, water is a very good heat transfer medium. The ethylene or propylene glycol is there to extend the ability of that water to perform in different conditions. Water is typically going to boil at 212 degrees Fahrenheit. It's going to freeze at 32 degrees Fahrenheit or 0 degrees Celsius. So we need to extend it past that. And that's exactly what the ethylene propylene glycol does. And then obviously the inhibitor package is there to keep things stable within the environment, to keep things clean within the cooling system environment. But as we push, returning back to, getting rid of the heat within the system, pushing that air through the radiator and condenser combination is very simple when the vehicle's moving. Obviously, that ram air is being generated by the vehicle moving. It's also supplemented by the cooling fans. So whether that cooling fan is a mechanical or electrical fan clutch, depending on the vehicle and sophistication of that vehicle, or whether it's electronic cooling fans that are being controlled through the PCM or some other brain within the system. We've got, the different various ways of, moving air through the system. Strangely enough, last week on my 2011 Ford Edge, I had both cooling fans go out. And I suspect that one of the cooling fans had been out for a while, but the other cooling fan had gone out. And quite honestly, that was a very nervous 5-mile drive home, to get that vehicle home, hoping that the ram air would keep my temperature stable, which it did. Fortunately, it wasn't anything more complex than that. But these fans go out. There are various strategies that go along with these fans. So they may be 1-stage, 2-stage, high-low type fans, or maybe one fan with the various stages integrated into that. Like I said, it's controlled through one of the brains in the system. Once again, it's very important that we recognize that is absolutely critical. If we don't have that ram air going through the radiator and the condenser, then we're going to have issues. Obstructions of any type in this area are critical. Leads, debris, humidity, dust on the fins of the radiator condenser can cause problems with airflow. If the vehicle's been in an accident and the air dams have been compromised, we're going to have issues getting air through there. So once again, it's very important to recognize, all these different things that occur at the very front of the vehicle and can affect how that coolant is going to react. Now, as we move through the bottom part of the radiator into the lower hose, we've significantly cooled down the temperature of the coolant, and we're moving toward the water pump. And this is really where, and I've kind of predated myself on this, but this is where the coolant is absolutely critical. The condition of the coolant is absolutely critical, because if we have dirty or if we have compromised coolant, then we're going to be to affect not only the water pump, but the operation of the water pump and the seals, and the chances of getting some type of weep hole leak because we've compromised those seals. We do a presentation where we dive into the water pump a little bit further and talk about this. So if we have the opportunity to do that for you, it'd be a pleasure to be able to do that. We're not going to get into a lot of that right now, even though we will entertain any questions that you have on that. We'll talk about that as much as you want. But once again, as we pass through the lower hose into the water pump, condition of coolant is absolutely critical. And obviously, we then move the coolant around the system. We're picking up heat. The water is the heat transfer medium, is picking up that heat, and we're routing it around. One of the other critical components within the system is the thermostat. So whether it is a standard thermostat, that's run with a heat motor or a wax motor, or whether it is a MAP, thermostat that is controlled, through, once again, one of the brains within the system, that thermostat is absolutely critical. And that thermostat is also going to be affected by the condition of coolant that's in the system. So it's absolutely critical, once again, that those systems are as clean as you can be. Gates does not sell, or Gates does not represent, or Gates, really has no affiliation with any of the coolant manufacturers. Like I say, there's a bunch of good ones that are out there. But what we do recommend when you are changing or adding coolant to the system, our recommendation is that you are using the coolant that is specified for that particular unit. Once again, there are a lot of different ways of dealing with it. There are a lot of different things you can do, flushing out old coolant, putting in new coolant, situations like that. But our recommendation has always been to go back into that system with the coolant that was designed for that system. There's a very specific reason that system was designed to use a particular type of coolant. Whether it's the metallurgy that's used in the engine, whether it's, a particular type of inhibitor, whether it's something that's compatible with the gaskets and, sealing materials that are in that system. Once again, there's a reason that coolant has been recommended. And once again, it's Gates' recommendation that we go back in and, and add that. Now, every once in a while, and this is typically more of a heavy-duty situation, but sometimes coolant additives are necessary. Obviously, within heavy-duty systems using inorganic technology, you're going to have your supplemental coolant additives that you're going to put into this system, all well and good. But what we really want to stress is that any additives that you put into the system should not contain any type of petroleum products or petroleum distillates, because those types of materials will begin to react and act against the rubber compounds that are in our hoses. It will begin to work at the rubber. It will begin to work at any adhesives that may be in that hose. And so once again, that is something that will begin to affect the hoses. So if you're in a situation where you have been using an additive like that, and you're in a situation where you have to replace a hose, it would probably be a good idea to be replacing all the different hoses, because once again, that additive has come in contact with every hose in the system. So what are we looking at in terms of simple hose failures anymore? Once again, EPDM has been around since 1990. So a lot of the old failures that we recognize with chlorophene rubber don't really exist anymore. But once again, that can be a false statement, because if we have certain conditions within the system, then they're going to accelerate the wear within the vehicle and accelerate the wear with the hoses. So let's take a look at some of the things that are happening with hoses. Now, obviously, if you're taking a look at a hose and on the outside, that hose is getting extremely hard, okay, that is usually an indicator that you've got a tremendous amount of heat that is either surrounding that hose or that is flowing through that hose. And so that hose really needs to be taken a look at, because as that hose hardens, as it becomes more brittle, as it becomes more dense, then that's really going to affect its ability to work with the stem that it's connected to. Because once again, hoses are intended to be a flexible connection. If that flexibility is not there, then it's going to really begin to wear on the stems and the components that those stems are attached to. So once again, it's something to take a look at there. The other thing we want to take a look at are some of the various items that I'm going to show you here. And once again, EPDM is more resistant to a lot of these environmental and a lot of these concerns. But once again, if the heat is excessive or whatever, then we will see these types of failures. So the first thing we want to look at is, our clamping. What's happening right there at the stem. It used to be, if you had a warm dry clamp, you just wanted to crank that thing down. It just felt good to get it tight. But you see these examples where you've got hose that is literally extruding through the openings of a warm dry clamp because, one turn wasn't enough, 5 turns, make me feel a lot better. So, you would see those situations. So that's not good. We don't want to really squeeze the hose down. Once again, we can cut the hose. We can cause problems there. But conversely, we don't want it too loose either. Really our recommendation is, and we do a presentation on water permeation and cold water leaks where we talk about the effectiveness of various clamps. And there's absolutely nothing wrong with the worm drive clamp. Worm drive clamps are used in a lot of different situations and are perfectly fine. But really, in testing environments, they rank third on the list. Shrink band clamps, if you're familiar with those, polymeric clamps that actually shrink onto the hose do an excellent job. The constant constant tension clamps are kind of second in line, and then third in line are the worm drive clamps. Once again, properly used, all three of them work just fine. The constant vibration within the system, especially if you've got an extreme heat load and things are becoming brittle, if the hose is becoming brittle, can really become an issue. And then if we have any type of petroleum, people pouring oil into the system and not being overly accurate, or if we have a leak within the system that's getting onto the hose, that's really going to cause problems, because what it does is it actually allows the hose to begin to separate, because the hose or the oil on the hose is very aggressive, and it begins to penetrate and it separates the three components. If you're not familiar with the construction of a hose, we have three layers. We have the outside cover, we have the middle part, which is the reinforcement, and then we have the inside, which is the tube, which is designed to convey the fluid through the system. So we want to watch out for that. The other thing, too, with petroleum contamination, if you begin to notice that your hose is becoming soft and spongy, or it's becoming sticky, that's one of the first things you want to think about. Now, one of the things to also remember is that petroleum contamination, both internal and external. And we can get that external drip, drip, drip on there, but also we can have internal oil contamination if we have a head gasket that's blown, or if we have other conditions within the engine that's allowing oil to get in and mix with the coolant, and that will begin to affect the hose on the inside. And once again, that becomes a situation where if you're having to replace one hose, you're going to want to replace all of the hoses, because that oil is going to have contaminated every hose in there. You can also get that soft and sponginess if you have high heat at the connection, kind of opposite of what you think you might see. Or you may see a hose that has just simply exceeded its intended life cycle. And that really, begins to happen between 7 and 10 years with the EPDM hose. The other thing that we can have happen is we can have reinforcement that becomes compromised. So this is typically, heat soak. Everybody's familiar with heat soak. Engine runs for a while, gets shut down. If there is no engine fan strategy to continue to cool off that engine, then literally we have a engine that is sitting there and just baking the components to death. So we have that heat soak that can really begin to compromise and make the internal reinforcement of that hose extremely brittle and begin to compromise it. So the other thing that can happen is just simply an engine that's running hot for extended periods of time. Or once again, we simply just have a hose that has exceeded its intended life cycle. So once again, if you see something like this, those are the things that could be causing that. Ozone damage, and we talk about the wonders of EPDM hose, but EPDM hose is susceptible to ozone. And once again, recognizing that in a lot of engines, today's engines, 60 amp alternators are still the norm, but we now have 200 amp alternators. We've got larger alternators working in systems. In some transit buses, there are actually 600 amp alternators. Not the norm, but once again, they're out there. So once again, vehicles needing, all of this additional energy, go to larger alternators. And alternators, when they run, give off ozone. Under the hood environment, there is ozone under there, and that ozone will begin to affect the hoses. So if you see this cracking, that is a potential ozone situation. The other one is that, perhaps the hose has just reached its, expected or intended life cycle. So you may see it there, but usually that is an indicator of ozone. The other thing you might see, and once again, this is pretty simple to look at, you may have abrasion damage, which just simply means that hose is coming in contact with something. There may be brackets that were never reinstalled, or perhaps the hose, was too long, or whatever the situation. But if you see any type of damage like that, that's typically abrasion, relatively easy to fix and diagnose. The other thing that occurs in hoses, and this is something that with gates, and I'll talk about this in a little bit, we don't see as much anymore, but it was ECD failure. And ECD, we'll talk about here a little bit, but it's electrochemical degradation. And that's when basically the cooling system becomes a battery because of dissimilar metals, perhaps a bad ground in the system, because of perhaps bad coolant. When I say bad coolant, I mean the condition of the coolant is degraded to the point where it's, it's more susceptible to carrying voltage through the system. This used to really be a problem with hoses. ECD, once again, is simply just current running through the system. And with hoses, you would get these striations, and these striations would occur literally within 2 to 3 inches from the stem where we're connecting to the radiator, a certain component. So the test for that was simply to begin to feel the hose with the engine cool, not with the engine hot, but with the engine cool. You'd squeeze near the hose, near the clamps, using your thumb, and you would basically kind of roll it, and you would check for weakness. And typically that would happen within that first 3 inches. And typically that would usually be the upper hose that you would see these particular issues. But once again, with ECD, and the way that we develop our hoses and the combination of materials that we use, we've made them what we call ECR, which is electrochemical resistant. So all Gates hoses are ECR, and we don't see this very much. So if you see discoloration, let's say at the tube of the heater core, if you're seeing discoloration, near the radiator or whatever, that's typically a sign of electrochemical degradation. So what you're going to have to do at this point is you're going to have to check the coolant for voltage, because you may not see it necessarily apparent in the hose itself. So how do we do that? Well, the easiest way to do that is to simply just use your digital voltmeter. You're going to set it to DC volts. You're going to connect the negative lead to the negative battery post, and then you're going to submerge the positive lead into the coolant. Now, you want to be careful you don't touch any of the sides or any part of the coolant bottle or actually in the radiator itself. But what you're looking for is you're looking for a voltage reading. Anything over 0.3 of a volt is an indicator that that system is carrying charge. Now, a lot of people would argue that if you see any current in the coolant, that's bad. But the breakout point, kind of the watershed moment, is that 0.3 of a volt. That will tell you that you've got excessive voltage that's running through the system. Now, when you take your first reading, you want to take the first reading with all the accessories off. If you see abnormal voltage in there, then that tells you may want to start checking your ground straps. If it's not the ground straps, then you want to turn your accessories on, and then you want to begin to shut off accessories and begin to see if you can isolate where that current's coming from. But a lot of times, what happens with electrochemical degradation, you've got the current that's running through the system, is that it's usually typically a bad ground, which is relatively easy to fix, or you've got current running in the system and you've got compromised coolant. So how do you fix that? Simply the easiest way to do that is to flush the system. You see the image down in the bottom left corner, that's our Power Clean Flush tool. If you need more information of that, I'll kind of lead you to that at the very end of this presentation. But it's a very simple way to use air and water, no chemicals, nothing like that, to flush the radiator, the engine, and the heater core. It does a fantastic job. And once again, like I said, I'll lead you to more information about that tool here at the end of the presentation. So let's talk a little bit about modular hoses now and what's going on with modular hoses. I've got these 3 images up here because basically they represent kind of the breadth or what's going on with modular hoses. So this is the big, this is the high, this is the 50,000 foot look at modular hoses. So let's take a look at the image on the left, part number 22-318. This is technically a modular hose, okay? A modular hose, by definition, is any hose that has one or more components designed into it that coolant flows through. So once again, if you've got hanging straps or something like that on a hose, that's not considered a modular hose. But a hose that has any type of branch or has any type of connector on it that you typically wouldn't find on a typical molded hose is what we would consider a modular hose. So in this particular situation right here, this is a very simple hose. You're going to be using a constant tension or constant diameter polymeric clamp to attach it, and coolant is flowing freely through this hose. There is no purpose, there are no restrictions, anything like that within this hose that is manipulating the flow of the current or coolant through the system. So once again, very simple, but if you take a look at that image, you'll notice that we have connections that are coming into one area. And one of the common problems with a modular hose is during repair or in high heat situations, high vibration situations, those areas can crack. So once again, that would kind of be the situation with that. Now, if we look over on the far right side of the image, what we're looking at there with part number 24120 is we're looking at a fairly sophisticated modular hose. We have a female quick or a male quick disconnect on that. We've got a number of different restrictors that are in this particular system. This is a hose. This fits a 1999 to 2001 Volkswagen Jetta, 2.8 liter V6. It's the throttle body to cylinder head hose. And once again, it's got a very specific purpose. And if any of those parts where the restrictors were removed and just replaced with a normal heater hose or small inside diameter hose, there's a good chance that we could cause some other additional issues within that system. So once again, when we replace these modular hoses, especially when they have purpose, they need to be replaced as a modular hose. The other hose that's in there, this is kind of unique. This hose right here, part number 24065, fits 2004 to 2006 BMW X5s, 4.4, 4.8 liter V8s. And the interesting thing about here is that once again, there are no singular purposes to each one of the connections, but you've got 5 female quick disconnects on that. And the issue with that is these quick disconnects can be very susceptible to damage, whether it's on the vehicle with the heat and the vibration that is occurring, or when they're taken off, or when they're kind of maneuvered into place to get out of the way if we're doing some other component repairs. So once again, it's just very important that we take care with all of these parts and make sure that, that we're, treating them right when they're off the vehicle. If there's any question as to whether or not that hose is going to perform properly when it's reattached to the engine, obviously Gates' suggestion is to replace the entire modular hose. Yes, there are cheaper ways of doing it. You can attempt to replace the O-ring. You can attempt to replace the clip, but that's an iffy proposition. If it works, great. If it doesn't work, once again you have a customer that may be in a situation where they're stranded. So let's take a little bit closer look at modular hoses and see what some of the various components are here. So once again, a modular hose by definition is a hose that has some type of components, some type of bracketry, some type of quick disconnect on it that makes it different from a simple molded hose. So once again, we may have branches. We're separating off the direction of coolant. We may have check valves that are within that. And those check valves may actually have individual thermostats within those that is controlling the amount of fluid that is moving from part to part, or when that coolant can move from one part of the system to the next. We may have filler necks that are installed on these particular hoses. Obviously the quick disconnectors in order to attach. Manufacturers, the OEMs love these things. They just attach to the system and it's quick, it's easy. It increases their efficiencies on the manufacturing line. Some of these hoses may also have sensors and sensor ports that are tied into them. And once again, these can be problem areas. When sensors are taken off, the damage to the components that are there can occur. So once again, we need to be careful with those. These hoses may have flow restrictors in them, that are, decreasing the amount of flow that runs through the system. And once again, as I mentioned before, branch-ins and quick disconnects, or we may have bleeders and drains within the hose, or just any number of different things that can occur. But these hoses, once again, even though they are simple port-to-port connections, so to speak, there's technology that's integrated into that makes them different than the standard molded coolant hose. So let's talk a little bit about what's going on in the marketplace. What's happening, with molded hoses, and why are they, so important? So we're going to take a look at some of the statistics that revolve around the cooling system. So if you take a look at the graph in the bottom right, this is a IMR or IMAR, graph, and basically what it's showing is when certain components are replaced. Gates has been strong on a strategy that we call Inspect at 60 and re-inspect or replace at 90,000 miles, because we really begin to see an uptick with all of our products at around 90,000 miles and the replacement. So if a part has lasted 90,000 miles, that's great. But chances are, based on this information, there could be a significant uptick as we approach that 90 to 100,000 mile mark. Once again, recognizing that engines can, they develop a tremendous amount of heat. It's very important that all of the cooling system is working properly. That means not only the major components, the water pump, the thermostat, the heat exchangers, but also the coolant hoses. When we take a look at component failures, a lot of it is tied a lot to the condition of coolant. With our water pumps, and once again, we do these water pump sorts, over 66% of all the warranties are due to seal failures. Over 95% of the seals that fail have clear and visible evidence that that failure was caused by coolant contamination. Once again, whether it was fine particles in the coolant, or whether, and once again, a lot of people don't recognize this as contaminated coolant, but if we have cross-contaminated coolant, that can also affect how those seals are going to perform, how that water pump is going to perform, how that coolant in general is going to perform. Once again, that's a conversation that we dive into very deeply when we do our water pump presentations. One of the other interesting things that we see is that 95% of the water pump claims that we get indicated there was absolutely no flushing done to that system. So there are a lot of water pumps that are getting bolted onto systems, and yes, the radiator's getting drained at that particular time, but that's only 2/3 of the coolant. The other 1/3 of the coolant is captured within the engine and the heater core. And once again, if that mixes with the new coolant, we can have issues down the road. We see that 91% of the times, technicians are going to put the old hoses back on because they see that, they don't see the damage that they used to see with them. And once again, our recommendation is if that system has, 90,000 miles on it or close to it, and that system has been open, that cooling system is open, it's a good, smart recommendation to replace the hoses there. It doesn't add that much to the cost of the repair, and it adds a tremendous amount of longevity to that. So once again, one of the things that we suggest is that when we're working in a system, one of the primary things that we look at is that we flush the system, and the other primary is that we're replacing that coolant with the antifreeze that was designed for that system. We're making sure we got a 50-50 mix, and that the water we're using is a distilled or a deionized water. So as we move away from, just kind of standard hose failures, and we begin to move into what creates a modular hose failure, we've come a little bit more defined in what we're looking at, but we're looking at kind of the same things along the way. Modular hoses are designed, and we'll take a look at the plastic components first. Modular hoses are designed with these quote-unquote plastic components. Well, the plastic is actually a very highly engineered injection molded material that is obviously different than just normal plastic, but over time and exposed to the heat that's in the engine environment and exposed to the vibrations that occur within the engine environment, they can become brittle and they can break. So just on the vehicle, they can break. And there's any number of instances where these modular hoses on vehicles just break. Some of them relatively quickly simply because of the design. And the OEMs or the aftermarket has to go in and kind of redesign that bracket or that reinforcement in order for that not to happen. But this happens on the vehicle, but it also happens during just normal service. So whether it's cooling system service or whether it's another type of service, if that hose has to be disconnected and moved, and everybody's done this where you take the upper hose, you take it off, you pull it off to the left, to the right, you kind of hook it in between, something else, and you kind of hold it there. That puts added stress onto a part that's already been stressed. And so once again, we can get the crack there. So the recommendation there is that if you're reusing the modular hose that's on this system and it has these plastic connectors on it, be very sure to check those connections, make sure that that vehicle is test driven, make sure that you do not have a compromised joint within this system that could lead to a problem down the road for the customer. So what we also look at with these systems is we take a look at the rubber materials. And in this case, it's going to be the O-rings on the connectors. And there's a lot of information on this slide. But basically what happens is that you've got the O-ring. That creates the sealing surface between the female and the male connector. Does a tremendous job, does a fantastic job. But over time, the O-ring is going to take on the profile of the two, the male and the female, that are seated together. When that connection is broken, that O-ring is going to continue to hold that profile. And then when those two units are reconnected, we may not get a matchup of that profile. And so we may create a leak point at that area. The other thing that can happen too is that the actual connector itself can become damaged. So whether that plastic has warped, whether that plastic was damaged, due to heat and becoming brittle, or whether it was damaged when it was taken off the vehicle and kind of wedged in between another part in order to keep it out of the way, you can actually create problems there. So once again, it's important to inspect these things. Obviously, in the aftermarket, there are O-rings that you can purchase that will fit that. Make sure, because a lot of these connectors use very specific O-rings, that you're getting the proper one. The Gates' recommendation on this is that if you have any question about the viability or the strength or how that hose is going to hold up, we suggest replacing the entire hose. Yes, it's a little bit more expensive, in some cases a lot more expensive option, but it is the recommended way to make sure that the customer is going to have a complete and full repair. The other thing that can happen with these is that the snap rings or the U-shaped clips that are on them can become damaged. So once again, need to be careful and watching out for that. So we're not going to remove, or we're not going to re-go over all of these points because we've talked about these. But what we do is we just kind of want to recap what's going on here. So the items that you're looking at, they're wear items. And if, once again, as I just mentioned, if there's any question on how that hose is going to perform, you need to make sure that, that you've tested it, and that if it needs to be replaced, that it should be replaced. When you replace it, you want to make sure that you are using an OE exact equivalent. So you want to make sure that all of the components, all of the purposes that are within that hose are within the hose that you're using to replace, because once again, if not, there could be potential damage to certain components. We had a situation one of the product managers was talking about not too long ago with a Lincoln, where we kept blowing out, or where they kept blowing out heater cores, and they would replace hose. They replaced the hose probably 2 or 3 times. Couldn't figure out why that heater core was being compromised. Eventually made a call to our product application team. Product application team said there is a modular hose for that. That modular hose has a flow restrictor in it. They replaced that hose with the flow restrictor in it. They replaced, with the modular hose, and lo and behold, no heater core problems after that. So once again, it can make a difference. We want to be system smart. So let's take a look at some of the trends that are occurring with motor hose, and we'll kind of go through this fairly quickly. So if you take a look at this chart, what we're seeing is that on the left-hand side, we are looking at a combined look, domestic and import, of what's going on. Within 2013, in the year 2013, 51% of the replacements that were occurring were due to component failure. By 2018, that had gone up about 4%, not huge, but we see a trend where, because of preventative maintenance or the lack of preventative maintenance in a lot of situations, those hose failures are going up. Those hoses that were replaced during preventative maintenance actually decreased from 2013 to 2018. So that was kind of a disturbing trend. If you take a look at the trend, and this is in the United States, if you take a look at the trend between the do-it-yourselfers and the do-it-for-me's, in 2013, there were significantly more people having the work done at a shop. And in 2018, there seemed to be a few more people that were doing it for themselves. So once again, there's a little bit of difference there. Now, if we separate out the import and the domestic, we can see that imports have a little bit lower percentage of product that is failing initially. Now, when we talk about imports, we're talking about Asians and Europeans combined, and you'll see in a chart that we're going to look at a little bit later that the Asians are really not really deep into modular hoses, whereas the Europeans are really big into them. But you can see the statistics there. And once again, one of the things that occurs is that import vehicles have a tendency to go back to the shop, where domestic vehicles, still plenty of them go back to shops, but there seems to be a little bit more do-it-yourself involved there. So let's talk about who is actually using modular hoses. Modular hoses, once again, the European imports are using them a lot. Domestic vehicles are using them in a fairly large number. Asians are starting to catch on, but still, a fairly low percentage of modular hoses there. So once again, you'll see them more on the European and domestic vehicles than you will Asian. And here's kind of another interesting fact, from the distributor side, that if you take a look at the very bottom, this has been increasing over the years, but in 2018, modular hoses made up only 17% of the entire volume of hoses, but modular hoses, in terms of dollars, represented better than 1/3 of the dollars that are generated in wholesale. So once again, modular hoses are significantly more expensive than just simple molded hoses, and they do have a tendency to have their issues. They have a tendency to fail more often for various reasons than straight rubber molded hoses. So as a wrap up, these hoses, they're a great addition to the vehicles. Once again, engine management strategy kind of dictates that we are routing coolant around the system differently and better. But once again, if there's any concern with that hose, if there's any issues with that hose, it should be replaced as a unit. And once again, that can do with a lot with the system and how it's developed. It can do a lot with how that hose connects to its port, and it also can be mostly about the purpose of that hose. So once again, we always suggest that if there's any concern with that hose, it's replaced as a unit. And once again, that that really is a plus for the customer. It's going to minimize the comebacks. For the shop, it's going to increase profitability. But the end run, the customer is what keeps us in business, and it's going to keep the customer, off the side of the road. So once again, it's very important. But there's a lot to modular hoses, and once again, we appreciate you being here today to learn a little bit more about it. Now, I did promise you, or I did say a little bit earlier, that we had some information that would guide you to some different areas. So if you're interested in the Power Clean tool, you can see those buttons in the center of the screen. And if the presentation that you get or is available to you doesn't, those clicks don't work, I will make sure that Priscilla has the ability to access those. We also have a app that you can add to your phone. It's called Navigates, which is a great tool for looking up parts and finding parts for particular vehicles. And then if you're interested in more learning, we have the Performance Center, and we have other opportunities for you to learn more about our parts. So with that being said, Priscilla, do we have any questions or any comments?
No, it doesn't look like any questions or comments have come through at this stage.
Okay.
Which means you must have bamboozled them and covered everything they needed to know.
Or I put them to sleep.
Good morning. Good morning, Frank. It's Chris Martirano here. Look,
good morning, Chris.
Good morning and welcome, and thanks again for taking the lead on this presentation. And thanks for a very thorough dive into the cooling system and cooling hoses and modular hoses, and in general the cooling system as a complete system. And it's really important that everyone on the call does understand that it's not one component in isolation. It's a series of components performing different functions and tasks. And I guess for me, the cooling system is one of those systems in all our vehicles, and that's plays such an important part in ensuring that our systems operate efficiently, effectively, and give us the best possible performance. But in my view, it's by far one of the systems that's most often forgotten and overlooked by technicians, and that's that's sad. I mean, it's from the simple and flexible hose connections to complete modular systems. I think it's important that the technicians do get the opportunity to have a look and inspect these components and make sure they're operating efficiently. So I think your presentation there has certainly sparked some interest in a lot of people out there, and hopefully they're going to take a few things back to their workshop. So
absolutely, I appreciate that. And I think you're absolutely right.
Yeah, look, the other thing's the interesting part, the material evolution from the Coolant product that we used to see, 20, 30 years ago to today's EPDM, and effectively given the hose, double the hose life and durability of that hose. It's a key to the functionality of that product, and also to the OEM car builders that are using our products to make their products. So, the evolution of that material has been a real big important step in doing that. The failures were also interesting, from the clamps too tight or too loose. I'm guilty, one extra turn, come on, make sure it won't come off. I'm guilty of that, but I've learned a little bit there as well. So just tight enough is what our recommendation is. From current running through that cooling system and the electrochemical degradation and the consequences that could have. Broken fittings, who thought modular hoses, they seem bulletproof, but the fittings do break. The fittings certainly do break depending on their location in the engine bay, and the hot, cold cycling through those components or through those plastic materials do cause them to become brittle over time. And look, we've seen the failures, and we've seen them all from the abrasion as well. That's a fairly common one when the hose is rubbing up against another component. So very, very good, well-rounded presentation, Frank. I really thank you for taking the lead again, and being able to present that to our audience throughout Australia and New Zealand today.
Well, once again, I truly appreciate being invited. It's a pleasure to work with you all. And once again, if there are any comments or any questions, just route them through you all, and we'll be happy to answer them, as quickly as we can.
Excellent. Excellent. Now, for those that want to be able to share this presentation, it will be online, and we'll give you instructions on where, a link that you can view this presentation. Again, it will be a recording of the whole thing, so share it with your colleagues or workshop or any person out there that you think might benefit from it. So from me, back over to you, Frank. You can wrap it all up.
That's fine. Once again, Chris and Priscilla, thank you very much. Appreciate it. It's been a pleasure, and hope everybody has a great day.
Great. Thank you, Frank.
Awesome.
Thank you.
Frank, thank you. Thanks so much.